Hi everyone, and welcome to our module on connective tissues 1. Connective tissues are one of the four major tissues in the body, alongside the epithelial tissues, which we talked about in a previous module, and the muscle and nervous tissues, which we'll talk about in a separate module. The connective tissue is unique in the sense that it tends to consist of a combination of organic and inorganic elements, and this combination is derived from embryonic mesenchyme that lies under the epithelium or under epithelial tissues and then to subserve functions of metabolism and structure. Um, Compared to the other three forms of tissues we have, connective tissue is the most abundant type of tissue. It's found in all parts of the body, in all organs. An organ will have a form of connective tissue present within it. It tends to connect different body tissues or different body parts to one another, and it never gets exposed to the outside environment. If you know anything about tissues, most tissues tend to, or most organs and structures tend to be lined by an epithelial tissue, and tends to be structurally maintained by the connective tissue. So the connective tissue serves as a backbone or foundation to most of the organs, whereas the epithelial tissue, which we talked about before, serves as a form of lining or coating, outer coating for those organs. The connective tissue is also highly vascular and also has abundant supply of nervous tissue or innervation. It is uniquely um, intercellular in its constituents. So most of the component of the connective tissue is made up of its intercellular component or space rather than its cellular component. So it's largely interstitial space and just few cells that are present within it. Let's talk about the functions of the connective tissues. There are multiple functions of the connective tissue, and this depends on, or this is by virtue of the fact that we have different forms or different types of connective tissue. We'll talk about different classifications very soon. In terms of the functions of connective tissues, first will be structural function. It's involved in providing the structural framework for the body, for part of the body. um, Organs tend to be structurally maintained by their connective tissue, and even a very unique form of connective tissue known as the bones tends to provide that skeletal framework for the entire body. So, aside the function of the connective tissue to maintain structural integrity in an organ, it also maintains structural integrity in the entire body. It also serves the function of support, of protection. Protection is very unique. Protection and immunological defenses as functions are very unique because a very specialized form of connective tissue, which is the blood tissue, is involved in doing this. It serves as a form of energy store as well. Most connective tissues also tend to have some form of storage of energy within them. Um, for example, the blood contains a number of different constituents, including nutrients and glucose. Um, and then we have the transportation of materials, also done by the blood. The blood contains hemoglobin. Hemoglobin helps in carrying materials like oxygen and carbon dioxide. The blood itself carries nutrients and metabolites, like as I said before. So these are the various functions of the connective tissue. If you're thinking about connective tissue and you're just limiting it to just structures found within different organs, then you miss the big picture because connective tissue is made up of a number of different forms of varieties of tissues coming in different shapes and sizes. So bones, for example, are regarded as connective tissues. The blood is regarded as a connective tissue. Cartilages are regarded as connective tissues. I'll talk about each of them as we move on along the slide. Let's talk about the features of a connective tissue. Connective tissues tend to be made up of two major features. First would be cells, and next would be the extracellular matrix. Remember, I said that it has largely more interstitial space than it has cellular components. So the cellular component of the connective tissue is very, very fewer compared to the extracellular matrix, which is the interstitial space of the connective tissue. But have this at the back of your mind. So when I think about the connective tissue, I think about the best example as a Nigerian that comes to my mind is thinking about Gary. When we take Gary, when we are soaking Gary, we have the different grains of the Gary being embedded within fluid. So think about the fluid as the extracellular matrix, and then the Gary aspect there as being cells. So that's how usually connective tissues tend to be described in terms of architecture. So in terms of that analogy, the Gary would have more water there, and then the Gary grain or the Gary structure itself will be found within the fluid aspect. So to break down the various components of a connective tissue much further, we're talking about the cells. Cellular components tend to be divided into fixed cells and wandering cells. We'll talk about what each of these entails. Examples of fixed cells include cells like fibroblasts, like adipocytes, like persistent mesenchymal cells. Then we have wandering cells, cells like macrophages, mast cells, plasma cells, pigmented cells, eosinophils, and neutrophils are examples of wandering cells. Then for the matrix side, for the extracellular matrix side, matrix tend to be divided into two parts. We have the ground substance and we have fibers. So we have extracellular ground substance and we have extracellular fibers. So ground substance are like combinations of protein and carbohydrates mixed together in large quantity, and this makes up a chunk of the entire extracellular matrix. So examples of the ground substance would be things like proteoglycans, like glycosaminoglycans, what we call GAG, and then examples of fibers. Fibers are just protein structures that are geared to maintain the strength and elasticity of the matrix. So examples of fibers would include collagen, elastin, and reticulin, or you can say elastic fibers, collagen fibers, and reticular fibers. We'll talk about each of those different components of the connective tissues as we move on along the slide. So starting with the cells, like I said, cells typically account for only a small fraction of the tissue volume in the connective tissue. They're divided into two major types. We have the fixed cells or non-mobile mobile cells, the cells that just remain in a particular site within the connective tissue. Then we have wandering cells. Wandering cells are mobile transient cells. They are always moving from one point to the other point within the connective tissue. Look at a picture of how a connective tissue looks like. You can see we see very little of the cells and we see more of the matrix. The cells are shown here. This is a cell here. This is another cell here. We can practically count the amount of cells present here. Just 3 to 4 cells are found in this particular image, and cells they are, as described, different, diverse in the fact that they can either be fixed or wandering. You could see some fibroblast here is a fixed cell, adipocytes also a fixed cell, macrophages a wandering cell, mesenchymal cells they're also fixed cells. So you have a combination of both fixed and wandering cells. So fixed cells, as I mentioned initially, includes fibroblasts. Fibroblasts are usually found in dense and loose connective tissues, and they are involved in repair of cells or repair of an organ damage or tissue damage. We have macrophages as well. Macrophages are part of the immune cells that are migrated from the blood vessel into a tissue, and they're usually involved in immunological functions within the tissue. We have adipocytes, adipose cells, cells found in loose connective tissue. They're usually cells that are involved in storage. So remember I mentioned the fact that one of the functions of connective tissue is involved in storage. Some of the cells that are involved in storage will be adipocytes. Adipocytes tend to store fat that has been converted from glucose, and they store them in large amounts in case of scenarios where we need them, which they usually are converted back to glucose for production of energy. Then we have mast cells. Mast cells are also immunologic cells found within tissue. And then we have undifferentiated mesenchymal cells, which are stem cells that tend to replenish every other cell within the connective tissue. Then wandering cells include cells like lymphocytes, plasma cells, these are immune cells, neutrophils, eosinophils, basophils, and monocytes. All the cells, if you pay attention, are all immunologic cells that are found at different points within the tissues, and they're found largely in blood. Please do note that this list of cells, whether fixed or wandering cells that I had listed on my slide, is not exhaustive. We have other forms of cells found in different other connective tissues. So for example, in bones, we have the osteoclast, the osteoblast, we have the stem cells for the bones. For cartilages, we have chondrocytes and chondroblasts. So each of the different forms of connective tissue has wandering cells and specific cells found within them, and that's the point of this particular slide. Now let's focus on the extracellular matrix. The extracellular matrix is combined as a combination of two major structures: extracellular fibers, which are just proteinous molecule, and ground substance, which is a combination of protein and carbohydrate. So as shown, we see examples of some of the protein fibers here: elastic fibers, collagen fibers, and reticular fibers. So each of these fibers tend to differ in terms of their function and in terms of their structure. So for example, the collagen fiber, its primary function is to add strength to the connective tissue, and the fibers are tend to be composed of very thin collagen fibrils, and these fibrils are made up of structures we call tropocollagen. All right. For reticular fibers are very delicate fibers. They're fine networks of fibers that are similar to collagen. They look like collagen, and they also give a bit of support to the individual cells. Elastic fibers is unique in the sense that it tends to consist of a bundle of elastin. Elastin is the major structure found in elastic fibers, and this elastin tends to be wrapped around by a glycoprotein called fibrillin. So elastic fibers are there to maintain the shape of the connective tissue or the organ, and they then help in restoring the shape whenever there's distortion. So remember that elastic fibers has the word elastic in its name. Elasticity is just the ability of a structure to return back to its normal shape when it has been distorted, and that's practically what elastic fibers tend to do in a given organ, depending on whether it is found here in large amount or small amount. So let's talk about ground substance. That's the second aspect of the extracellular matrix. The ground substance is made up of a combination of high water content and proteoglycans. The water content could either be in solid, fluid, or semi-solid form. And what I mean by that is that we have different forms of connective tissue that have different texture of its ground substance. So, for example, the ground substance of a connective tissue like blood would be largely liquid, and the ground substance of a connective tissue like bones will be largely solid. Besides the water contents of the ground substance, there are also proteoglycans that are found there, and proteoglycans are practically carbohydrate combined with protein, and they help in maintaining that integrity present within the ground substance. Examples of some of the proteoglycans that forms the ground substance include the glycosaminoglycans, what they call GAG, and hyaluronic acid. So how do we classify connective tissues? We can classify connective tissues based on presence or absence of special properties or features, and we could also classify based on the arrangement or amount of some of the extracellular fibers that we talked about. So in classifying connective tissues, we have two major broad classifications. We have the connective tissue proper, and we have the specialized connective tissue. So examples or sub-classification of connective tissue proper includes the likes of the dense connective tissue and the loose connective tissue. We'll talk about that very soon. And then examples of connective tissues that are classified as specialized connective tissues include that of cartilages, bones, and blood. Connective tissue proper is divided into two major forms. We have the dense and the loose connective tissue. The dense connective tissue is further divided into two parts depending on the arrangement of the fibers present within it. So we have the dense regular connective tissue in which the extracellular fibers are arranged in a regular pattern, hence the name. And then we have a dense irregular connective tissue in which the extracellular fibers are arranged in an irregular pattern. So let's start off with the loose connective tissue. The loose connective tissue has very low density extracellular fibers. That's what distinguishes it from the dense connective tissue. So the loose term we're using there is that the amount of extracellular fibers present within this connective tissue is small in amount. So every other connective tissue is going to have its cells. It's going to have extracellular matrix. In the extracellular matrix, it's going to have ground substance and fibers, but the fibers are very low in density. Hence the reason why we call them loose connective tissue. In fact, look at the picture down below. You can see that if you compare the loose connective tissue to the other dense connective tissues, you notice that the amount of fibers there, you could literally count the amount of fibers present here. This is one, this is two, these three, about 3 to 4 fibers are present there. So we can count the amount of fibers in the loose connective tissue. So they are loose because of the low density of extracellular fibers. and they tend to include tissues that they tend to be included in tissues that tend to hold organs in place and attach the epithelial tissues to the underlying tissue. So they are connecting tissues in the sense that they connect epithelial tissues to underlying tissues. So what we know as, for example, the subcutaneous tissue of the skin, or the hypodermal part or region of the skin, is made up of loose connective tissue. Majority of the cells we find there is usually adipose cells, or what we call areolar cells, and this is usually what we use in remembering. So when you hear areolar cell or areolar tissue or adipose tissue, they are largely loose connective tissues. The dense connective tissue, this, as the name implies, has very high density of extracellular fibers within it and small amount of ground substance. And this is in comparison to what we saw for the loose connective tissue, which has large amount of ground substance and but small amount of extracellular fibers. The dense connective tissues are divided into two forms based on the arrangement of the extracellular fibers. We have dense regular and dense irregular connective tissues. So dense regular connective tissues, for example, have a large amount of um, fibers, usually collagen fibers, that are arranged in parallel. So you can see how these fibers are arranged. You can see that they are practically lined up side by side. This is an actual image of a dense connective tissue. You can see that we cannot really distinguish between the collagen fibers because they are arranged all in parallels. And this tends to give the tissue very great tensile strength. The tensile strength is as a result of the fact that they are arranged in a regular way. So as a result, it's very hard to separate them, and this is due to the fact that that arrangement gives or distributes the strength along the direction of stress. The two major tissues or sites where we find dense connective tissues tend to be tendons. Tendons are very strong, and then ligaments, which are also very strong structures. For dense irregular connective tissues, these have their extracellular fibers also being abundant, but they are arranged in an irregular fashion. So they tend to be arranged in forms of sheets with fibers that tend to interlace and they form um, different networks that branch out. So they're not arranged in parallel. That's the key thing to note. We tend to find dense, irregular connective tissues at sites like the dermis of the skin. So you can look at a picture like this. You see how wholly arranged each of the connective tissue extracellular fibers are in this particular image, and these are this is a typical representation of the irregular dense connective tissue. So to talk about the connective tissue specialized, we'll talk about each of the different forms of the specialized connective tissue in a separate module. However, just to recap them, we have three major specialized connective tissues. We have the cartilages, we have the bones, and we have the blood. We'll talk about them in a separate module under connective tissue too. And that concludes our module on connective tissue 1.